accidentally deleted the first part of the recording permanently by accident before uploading it to YouTube, so I'm gonna go over time variance versus time invariance part 1 again. So to check if a system is in time variance versus time invariance, you perform a time shift on the input, which is represented by h of x of t minus t naught. Forgot to put a bracket, but yeah. And then you perform a time shift on the output, which is represented by y of t minus t naught. And when you do that, if h of t minus t naught, if the shift on the input is equal to the shift on the output, then you have a time invariant system. But if a shift on the input is not equal to the output, then you have time variant system. Time varies. Okay, so let's go over this first example that I deleted. So, first example is y of t is equal to x of t minus x of t minus 1. So first I performed a shift on the input. Let me make this smaller. So after performing a shift on the input, what I'm essentially doing for the shift on the input is for every t I see, I just add a minus t naught for every t I see. So we have x of t minus t naught. I add a minus t naught to it, and x of t minus t naught, I add a minus t naught to it. And it doesn't just have to be x of t. If, let's say, there was a plus t here, then I'll still add a, let's say in the equation for the example, there is a plus t here, then I'll add a minus t naught to it. So it doesn't have to just be x of t. So that's how the time shift on the input works. The time shift on the output is a little different. What I'm doing is I'm substituting t minus t naught for t. So before I had a x of t, I'm just writing the example again, minus x of t minus 1. So for every t I see, I substitute a minus t naught. No, I substitute t minus t naught, not minus t naught. I substitute t minus t naught. Like that. And then after I substituted it, just replaced it, did the same thing here. For this one, x of t minus 1, I substituted t minus t naught. Add brackets to make it help. And what I'm supposed to do is I look at equation 1 and 2. I looked at both of the shifts. So shift 1 is equal to shift 2. That means it is time invariant. So now let me look at the second example. Y of n is equal to x of minus n. So what I'm doing is I do a shift on the input, and the way this works is I just add a minus n naught to a minus n naught, or no, to every n I see. So for this example, I added a minus n naught, obviously, and it doesn't just have to be x of minus n, it could be just n, and I'll add a minus n naught to it. And now I do a shift on the output. So now I substitute a n minus n naught for n, as you can see here. And after I do that, I get x of minus bracket n minus n naughts, which is different. So equation 1 is not equal to equation 2, so you have a time invariant system. So in the second video, I explained the other two examples. I wish I had the original for this because it was much better than the one I just made. I'm just really tired right now. So I hope you understood that. Watch the second video for more clarification. So yeah.